Alright, so we had a storm here last night, and it blew a bunch of stuff out. So what we're gonna do is we're gonna see if we can do an analysis on this and see how strong this wind was. Probably about 40-50 mile per hour winds got up and underneath this thing. It just pretty much blew off all that. But what we're gonna do is we're gonna do an analysis on this in GT STRUDL and figure out what happened. This is at our Hexagon headquarters here, or Houston location, you could say. Not the headquarters, but the Houston location. And so last night was a pretty bad storm. And it'll be interesting to see how this works, and we can reevaluate this thing and see and analyze this thing and see what was going on and what was the purpose of it. All right, so went outside, man, it's cold out there. That storm, I mean, you just saw that video. Just that storm just blew that carport just to smithereens, man. I mean, I wonder what we could have done better. I mean, I'm not no engineer, but I wonder what could they have done if they would have been done, or with some other software that could have been, you know, designed better or engineered better. So let's go and ask the professionals, because I'm not a professional in any of this. And so let's go see if we can find somebody in this Hexagon building that knows anything about that. Let's say hi. Hi. Hello. Yeah, so let's go find somebody. I know there's got to be somebody in here. Let me go down the hall here. Let me see. You know, what could have done? I'm looking for a structural engineer. A structural engineer would know more about this. I know Ravi's got to be. Got to be somewhere in here. There's Tyler, and I know find somebody. Let's see. I know there's a structure. Oh, I think that was Ravi. I think Ravi's here. Yeah, let me see. That's his name up there, Ravi. Let me see if he's busy. Hey, Ravi.
Yeah, just.
Oh my gosh, man's busy. Can't disturb him like that. Let's go and ask him again. Okay. All right, Ravi. So, you know, I was outside and noticed that there's this carport out there right now that, you know, it blew down. I mean, goodness gracious. I mean, was it made out of Legos or something? I mean, I was like, the wind wasn't that bad. I mean, you saw it. Have you been out there? Did you see that?
Actually, that's a great question. Today morning I was there before you. I drove in. I saw this massive structure fall down, and like you. You know, when especially like structural engineers like me.
Now you're a structural engineer,
yes,
right?
Yes,
you're a structural engineer.
Yes.
So I got the right person. So let's find out more. I'm gonna ask him a lot of questions. Okay, so I'm no engineer.
Okay.
You know, I'm no engineer. I mean, I'm a sales guy. Sales guys, we think we know every lot of things, but we don't. Okay, so how could GT STRUDL, which is one of many of our softwares that we have, this is specifically for structural engineering, how could it have helped the carport company design a stronger covered parking that could have withhold maybe 125 mile per hour winds, or you know, something like that? Because I think out there wasn't that windy.
No. So I mean, that's a great question, Mando. You know, firstly, when structural engineers like me see a failure of a structure like this, we feel bad and we feel like, okay, we haven't done our jobs right. So with just keeping that in mind, I came in, I took some measurements and photographs, as I said, and I said, okay, let's first study the problem. And I looked up the weather. No high wind warnings, no tornadoes, and the structure was probably resisting maybe 35 to 40 miles per hour wind gusts, and
it wasn't that bad, right?
We could have done much better than that. So let me show you what I have done so far.
Don't tell me you've already got an analysis already?
Yes, I have done it.
Oh my gosh.
I've done everything in STRUDL, and I'm going to show you what I've done.
In GT STRUDL?
Yes, GT STRUDL.
Sweet. Okay. This is an awesome thing, so I'm glad you did. So, okay, I guess show us. So show us what you did.
So I said, let's just see how we can design a better structure designed using hot rolled steel sections rather than using galvanized sections, and let's say we want to design for 120 miles per hour wind. So next time, Mando, you can actually park your Ferrari underneath this parking structure with more confidence. Just joking. But okay, so I modeled this structure in GT STRUDL for in about 10 minutes, and I was also done with the loading. So I generated the self-weight, simple self-weight command, wind loads using the wind load generation command, which it does ASCE7 wind load generation based on 120 miles per hour wind and other ASCE factors. And then I went in and generated these wind uplift loadings, because you would have suction loading also when you have these types of winds. And then we would go in and generate these load combinations with the load combination factors shown. Okay, so this was pretty much the simple loading that I came up with. And then what I did was I ran the analysis and then looked at the deformed shape of the structure. Okay, and if you look at the deformed shape of this particular structure, you can see it resembles the type of failure that we see on site. Okay, so I looked at these deflection numbers, and then I said, okay, let's put in these two columns here to have more redundancy in the structure. Okay, so then after that I ran the analysis again and looked at the deflection numbers, and they were better than before. And then I also looked at other things like if I go into results and look at force moment envelopes, moment diagrams about the z-axis for all members, let's say, you can see that the maximum bending moment like this for all these columns is right at the base, and that's the place where we saw the formation of the plastic hinges and where the beams columns actually failed. Okay, now then what I did was I ran the nonlinear analysis. I satisfied all the requirements per the AISC 14th edition code, the analysis requirements, and then did a code check. Okay, now here if I go into results, steel code check, and if I go into allowable stresses and I just say select all members, you can see that all members are within are less than or about in the range of 1 to 1.1. Okay, so this was based on the member selection that GT STRUDL did. Okay, so I asked the program to come up with the shapes when I provided the loadings and the analysis results. Okay, so we provided the results, the forces going into the structure. It did the analysis. Now we know the moments and the displacements, and depending on that, it came up with these shapes, and we accepted these shapes. We ran the analysis again, and here are the results. Okay, so this is the final design. It picks up one type of section for all the columns. It knows that, okay, all columns need to be the same, all beams need to be same in this case. And once this design has been finalized, you can take the physical model. Okay, so we have two options here, the analysis and the physical model. We can take this physical model into CAD work structure. Okay, now here I have a CAD work structure open, and what we need to do is go and click on this option called import, and you can select the import file here coming in from STRUDL. You can do a mapping on the sections if required. In this case, it was not able to recognize the 10 by 8 by 3/16. Okay, so I'm just going to go in and help it out with the mapping. So I'm just going to go and select square tubing, HSS section, and let's just say we have a 10 by 8 by 3/16. Okay, so that would be 10 by 8 by 0.1875. Okay, so if you click on OK, it'll remember that for future. If you save that and if you click on import, boom, it actually comes into your drawing generation program. In this case, it happens to be CAD work structure. Okay, and this is running on the BricsCAD platform, right? So this is the structure. We can also take a look at it in like the perspective view, and I can basically issue a render command here to get a nice rendered
that's
view.
how I would actually design it.
So that's what you would have done.
GT STRUDL, yes.
You are amazing.
Thank you.
Isn't this guy amazing? This guy's amazing. So let's end this. So GT STRUDL, really?
Yes.
I
So
mean,
in
how long did that take?
That took an hour, so
An hour,
yes.
and then what, you just use GT STRUDL
and CAD work structure
And CAD work structure.
to design. I mean,
what are you basing that? What's the? I mean, this is in what, BricsCAD or something?
Yes, this is BricsCAD empowered.
So both GT STRUDL and BricsCAD at the same time?
Yes. Yeah.
Wow.
So, in short, with the expectations of a better performance of the structure and using better materials and a better structural system, and of course, the best software, GT STRUDL, and CAD work structure, I was able to design this structure in an hour,
In an hour.
In an hour.
And so what can the wind, it can handle now, what?
As I said, 120 miles per hour wind would be...
So this would be a great carport in Corpus, huh?
Yes. Corpus Christi, you can have that on any of the LNG projects there. I've actually worked on one of those projects,
Wow, okay. So with GT STRUDL, with CAD work structure, and on top of a BricsCAD platform. And the BricsCAD, I guess you can, it has dual processors too. I mean, it's able to take, it's multi-threaded, I guess, so
Correct.
too. So, wow, I've never seen a structural program, engineering program, and BricsCAD like it's in a modeler.
Yes.
So you can model your way.
Exactly. You can model in this case, I actually modeled it using GT Menu, but you could have modeled the entire structure inside BricsCAD and run the analysis in BricsCAD. Even reviewed the deflected shapes and all that I showed you inside BricsCAD, and you could have done the drawing generation like I did here inside BricsCAD.
So there's multiple ways of designing. Yes. What are those multiple ways of designing? I could have done it in several ways in GT STRUDL?
Oh, yes.
So designing your way, what
Yes.
are those different ways?
You can go design it using the traditional way, which is using the input file. You can use the GT Menu option. You can use the structure wizard. You can also use the BricsCAD empowered GT STRUDL
Wow.
to model your structures. You could have even modeled it using CAD work structure and taken that model into STRUDL. You can go any way you want.
Oh, so you can go take that structure, bring it
Yes.
into STRUDL, then do the analysis, and
Yes.
then take it right back into there.
Yes, because different companies have different workflows. So in this case, I was the designer and the structural engineer. But hey, you could have been the designer and you'd create the concept of the structure. I take the model from you, analyze it inside STRUDL, and if I make any changes, I'll give it back to you and you can update your model.
Okay, before I leave, since I've got your attention,
Yeah.
I mean, does STRUDL also work with our other analysis products too? Like it also works with the Caesar too, right? It's able
Correct.
to export. Give me a quick. What is that? Is able to do with that?
Yes. Now, in this case, we looked at a carport structure, but there's similar structures that are used in the petrochemical and LNG facilities. So let's say you have a pipe sitting on a structure. We call it pipe racks. So any pipe rack structure, you can model it using STRUDL. But the actual support conditions inside Caesar are assumed to be either pinned or fixed. Now, certain types of critical pipe runs require you to actually do a combined structural and piping analysis. And with the current version of STRUDL, you can actually take a structural model and export it out into Caesar and run a combined analysis.
That's nice.
Yes.
So we've got interoperability between the two.
Yes.
So that's really nice, and that's important.
Correct, because like the failure that we saw today was a total disaster.
It's a disaster
It's a
out there right
disaster.
now. It's crazy.
And things like that happen. Like let's say you have a huge water hammer load on a site where you incorrectly operate the valve and there's a water hammer load on your structure. The last thing that you want is a catastrophic failure.
That was catastrophic out there.
Yes.
I mean, I can imagine what a piping structure in a plant.
In a plant.
And if that were to happen,
flammable liquids and
flammable liquids in here, nothing was flammable.
Yes.
Okay, so we don't need nothing blowing up in here.
Exactly.
Well, you know what, Ravi? I mean,
Okay.
this was awesome. I'm glad. I mean, I looked out there and I was like, what could we have done?
Yes.
And man, you're already thinking like, so genius. We're both geniuses here. Both minds think alike, you know. So, any of the last things before we say goodbye to our friends here?
Okay. No, thank you, Mando, for thinking about this, and I appreciate it. You know.
You are the man.
Thank
You
you.
are the man. He is the man. I like him. So, hey, if you want any more information about GT STRUDL, or if you want to talk to the man, the Ravi man, the Ravi man, the Ravi man. So you can talk to me. Look at my LinkedIn account. Also look at YouTube account. Also look at Hexagon's YouTube channel too as well. My information, how to get a hold of me, is right below in the show notes below. But other than that, I think we're done, right?
Yes.
Talk to you later. We'll talk to you soon. See ya.